Hey Chan Physics, it's Mr. Block, and I'm doing this quick video to go with GoFormative 3.06. Now remember, these problems are long and they need organization, but they are not difficult if you follow through with the way that we're teaching them. So make sure that you do that. And then remember that Mr. Broberg and Ms. Moise and I probably have a couple of different things that we do differently on how we set these things up. Okay. My classes, we draw boxes. Mr. Broberg has a much better ability to draw than I do, so he may actually draw the actual objects. But the bottom line is, you can see when we get to the middle part of the problems, they're going to be the same. Okay. So I only want to do a example problem that I just made up because we only have 4, and we really need you guys to learn how to do all 4 of those. So I'm going to do an example problem, and then at the end, I'll look at that first problem in this coformative, and I'll at least try to set it up for you guys. Right, so we have this problem that you guys can see up on the board. 2 hockey players are skating at each other in an intense game. Player A has a mass of 110, skating to the right at 5. Player B has a mass of 125, skating to the left at 6, and they're going to collide, and they're going to give some information about after. So what I want you guys to do, and what everybody else should know, is that when we I don't know if this box is showing up on your screen, but I want to get rid of it. What we do is we want to set up our organization. And so for my class, what we do is we say, okay, since Mr. Block can't draw anything, we're just going to draw boxes. So we have one box plus another. Okay, we represent an arrow for our collision, and we have our 2 boxes. Okay, that's how we're going to set up this problem. We're going to remember that this side is our before side, and this side is our after side. Okay. Once we have our boxes or our drawings or whatever else that you're going to do, we're going to name them. And so here we have players A and B, so we'll name them A and B. Okay. So now we have our organization set up. Let's just do a little bit of the learning. Remember what we said was that in a collision, the conservation of momentum is true. And so if we add up all the momentums before the collision, they're going to equal all the momentums after. So if we were to write that down, we could just say that P of A plus P of B should equal P of A plus P of B. Okay, this is momentum before of A plus B equals the momentum of A after plus B. Okay. So remember what we said was this was our first problem set that we had the quiz. Then we also know that momentum equals mass times velocity. And so in this problem, if you can see, they don't give us momentums, they give us masses and velocity. So we need to substitute. So for each one of our momentums, we're going to substitute. We're going to do m times v plus m times v equals m times v plus m times v. You have to be careful, right? These are pluses right here. And so these are 4 terms, okay? And we have to be careful with that. All right, so now we can look at our problem and add information. So what's the mass of player A? So I go in there, mass of player A is 110. And I'm going to multiply that times the velocity of player A before, which is 5. And since it's to the right, I'm going to make it positive. I'm going to keep my plus there. And then my player B has a mass of 125. So I'm going to make that 125. And now I'm going to multiply by the velocity of B before the collision. They say it's to the left at 6, which is a negative 6. Keep our equal there. Player A's mass, again, 110. And they tell us that after they collide, player A is moving to the left at 1. So we'll put in negative 1 here. Okay, player B still has the same mass, and they've asked us to solve for the velocity of skater B. So we'll change that V to V of B. All right, so now we've got that set up. Now what I have to do is do the math. So 110 times 5 is 550 plus 125 times 6. I'm going to test my ability in math, but I'm going to guess that that's 750. Okay, we could always have our calculator out there, but 6 times 125 is negative 750. Okay, that's going to equal 110 times negative 1, or negative 110 plus 125 times b of b. All right, now see how we're moving down. Okay, we can see everything that we're doing, and we can follow through to make sure that we didn't make any mistakes. Okay, we can check our information. So now we can just start combining things. So now that we're still in our columns, now we're going to be saying, okay, what's 550 plus negative 750? That's a negative 200 equals negative 110 plus 125 b of b. Okay. So now I got to get rid of this. And so many of us want to divide. But these are two different terms. Right? So we just got to get rid of this 110. How do we get rid of this 110? Well, we add a positive 110. In my math, we would do it over here. You guys might put it underneath. But we're going to add a positive 110 to both sides. Negative 110 plus 110 go away. And on this side, we get 125 times b of b. And here we get positive 110 plus negative 200. So we're going to get a negative 90. All right, now we're ready to say, okay, what is, how do we solve for v of b? Well, now we're multiplying by 125, so we're going to divide by 125 on both sides. All right, and this will cross out, and we'll get v of b is equal to a negative 90 divided by 125, or 0.72. Negative 0.72 meters per second. Right. Before I let you guys go, you can see that I took the entire sheet of paper to do this problem. That's what it takes if you're going to do it in order and you're going to take your time. And number two, what we really want to do is, again, look at this from a perspective of, does it make sense? Okay, so player B is moving faster than player A and has more mass. Therefore, it has a significantly bigger momentum. So when these two collide, player A was going to the right, player B was going to the left, it's likely that we could predict that both of them would be moving to the left. And that's what happened, right? Player A went to the left at 1, and player B went to the left at 0.72. And so the collision came in together like this, and then the two of them went like this fairly slowly afterwards. And that would be fairly predictable, given the fact that player B had more momentum, and so it's likely that the collision would go to the left. All right, so let me just pause real quickly and see if we can find. So I found the momentum 3 problem number 1, and it's just two balls colliding. And so when you guys start that problem, remember, you'll just draw your boxes. Your arrow represents your collision. You'll draw your other boxes. And then we're going to have ball A and ball B. So ball A and ball B. And what we'll do is, remember, we'll start out with momentum of A plus momentum of B equals momentum of A plus momentum of B. And then we'll substitute in. So we're going to have M times B plus M times B equals M times B plus M times B. Once you're there, now we can read the problem. Ball A has a mass of 0.4. So that's a mass of 0.4. And it is rolling to the right at 5.4. That's a positive velocity, 5.4, plus ball B has a mass of 0.5. So we'll put 0.5 in, and it's moving to the left at 3. That's a negative 3. Equals, okay, same mass for A, and they're saying A is going to be back to the left at 3.5, so negative 3.5 plus 0.5 for the mass of B, and that's what they're going to ask us to solve for, V of B. Okay, so once you've got that all set up, now we can do the math. We can get our calculator out, put this here, put this here, put this here, this stays the same, and then we'll do our algebra from there. Okay, so we've got the setup for problem 1 correctly. Remember your lefts and rights. Have a great day, and good luck.